let's take a look at a demo of the mini MVCS system and how you can have multiple minis in the same project. Now, why would you need to do that? It is a great question. I needed to have a drink of water just to think about it. So typically in a project, the reason that you bring on an off-the-shelf architecture like MVC, or specifically in this case, the mini MVCS framework, is that you want to set your project up to be more maintainable and more scalable as the project grows. Now, the first thing that you would do is create the mini structure, and inside of it, the model, view, controller, and service. Most of our demo projects have that level of complexity. If you want to add a bit more complexity into the project because the feature set grows, you could add another model, another view, another controller, another service, right? So you could have as many of those concerns as you want, all within the same mini. But you could also, another tool that you have at your disposal is to have multiple minis be in the same project. So imagine a game where the core game loop, let's say we're playing Pac-Man, taking the input of Pac-Man moving around, grabbing the power pellets, the AI of the enemies, all that core game logic could live in one mini, and you complete your whole game that way. And then you say, well, now we need to make a meta loop around the entire thing. We need to have multiple worlds. We need to have some social features. We need to have multiplayer. We need to have high score tables, whatever you're going to wrap around the core experience. You could add model view controller for that, or you could create a separate mini that is the meta game. And then you could have the core game mini and the meta mini talk to each other in a predictable way. So there's lots of different ways that you can scale up your project once you get mini MVCS incorporated into your project. So we'll take a look at a demo of multiple minis in one demo project. So this is part of a course, which is the MVC Architecture for Unity course. MVC stands for Model, View, and Controller. The high-level content is here. Even deeper looking at the course content, we can see that we've got different sample projects. So the course goes over how to create a simple clock, how to create a login, how to have the roll-a-ball Unity demo, where you have a ball moving with physics, collecting different cubes done with physics and scoring points. It's a classic Unity project. It's done for you here in mini MVCS in the course. And then there's a custom sample project as well. What we're looking at now is more demos that we've added on top of that. There's about 10 different ones, but the one we're going to focus on here is multi-minis. So let's take a look at that inside Unity. So here we are inside Unity. If you look at if you're in the course and you follow the course, you can download it that way. If you're in just grabbing the free code off of GitHub, then you'll have the mini MVCS here in your package manager. And you just want to go over here to the samples and import the samples. And then you'll have access to all we're about to see. Now that's already done here for me. And if I look over here in the more folder, we have, we got multiple minis here, right? So that's the one we've got set up. So in the multiple minis, we've got, let's just run the scene to start with. So here we have a left mini, which is a view model controller on the left side of the screen, and a right mini, which is a completely separate mini. So if you followed along and seen previous videos in the course or previous videos from this topic on YouTube from me, you'll know that generally in each demo, we have exactly one mini. But for talking about how you could scale up and those options I mentioned just a few minutes ago, this demo shows two minis here. So notice they look kind of similar. One is about 50% of the screen real estate on the left, and one is about 50% on the right, and they have quite similar looking layouts and stuff. That was just to have kind of some similarities here for symmetry. But they don't necessarily need to be logically or semantically similar in that way. You could have one, again, that's just the core logic of the game and one that's the meta around it. You could have one that is about 10% of the user experience and another one that is 90% of the experience. You could have even more than two. You could have 3, 4, 5 minis inside of a project. You could imagine creating a Unity package that is a mini and distributing that. And then people who have a mini-based project or a non-mini-based project could bring that package in and everything could work. So you can think of minis as their own little world and a lot of flexibility in how you integrate them. So here, what we do is we can click the increment counter button on the left, and it is updating the counter on the right mini. Now there's lots of ways you could structure this. It's a somewhat arbitrary example here to split this, but for the sake of demo, on the left, it takes input, and on the right, it renders to the view. So let's take a look at how this scene is set up. So here we have the world, which just hides the camera and the light, since that's not too interesting for our talk. Then we have the left view, which is the portion just shown on the left, and the right, which is the portion just shown on the right. Each of those are Unity UI canvases, if you care. Then down here, we have the multi-mini example itself. So this is a mono behavior that is the demo that gets everything started. And I just pass in a reference to the left view and a reference to the right view so that the demo can link them up together the way that it needs to. So let's start here by looking at the mini example. Let me zoom out a little bit. So this is a mono behavior. I take a serialized field of the left and the right. Then what I do, quite fundamental and important to this demo, is I create the context outside of the minis. And I pass the same context in to the left mini and into the right mini. Now, why is that important? The context, much like the typical word context in life, context is decisive. Context determines which options and possibilities present themselves as available to you. So if I pass the same context into the left and to the right, they're able to communicate to each other. They can, for example, send commands to each other or get a reference to the model for each other. They're basically living in one world. If, for sake of argument, I had a context 1 and a context 2, and I passed 1 into the left and 2 into the right, then left and right cannot talk to each other, right? That's part of the encapsulation of how object-oriented programming work, which is reinforced in how Mini works. But if you want to be able to communicate, then you pass the exact same one reference to both, right? So let's look at the example on the left. Takes in that left view, takes in the context that we just discussed. And it will do the initialization. So let's see how the initialization works. So what it does here is, let's see, there's different options that I mentioned here in the comments. You could do different things. But what I do here is I create the model here inside. I pass that universal context into the model. Then I pass the context into the view, and then I create the left controller. So let's take a look at the left controller. It's going to take a reference to the model and the view. Remember, model is dumb data storage, and view is dumb rendering to the user and taking input from the user. And down here, all I'm going to do is say, hey, left view, anytime the user clicks that increment button, let me hear about it. Then down here, when I handle that, anytime you've clicked the button and we've heard about it, I just update the view. Sorry, update the model. So by adding that value there. Now let's take a look at the right, what did I say? The right mini. So here I am with this, here we're back here. So the left one we saw takes the click and updates the model. Now let's look at the right one. So it's going to store the right view in the context, same as before. Now it's going to do something a little bit different. Instead of creating its own model, it's going to say, hey, context, do you already have a model with this particular name? And we know we do because the left one just created it. And here we're going to say, hey, right view, here's your context in case you want to listen to that universal shared context. And then we create the right controller. Let's take a look at that. Now the right controller here is going to, now remember the left controller said, hey user, did the user click the button? This one says, hey model, did the model change? And then down here, if the model changes, it's going to send out a command. So we've got different examples about how command is useful and how view can talk directly to the model. So throughout these demos, as you're looking at them, you'll often see I have different options that are communicated. So here in this demo, what we're doing is invoking a command. Now in the series, if you look at commands, you can think of a command is a reusable set of instructions that's sent through the context. And any concern that wants to can say, hey, I want to hear anytime that command happens. And in this case, I'm invoking the counter changed command. And if any of the contexts want to hear about that, they can. So that's it for this demo. Let's take one more look at just running it. So again, the left side here takes the input. I'll click the increment button, 1, 2, 3. And the right side renders the output. So it's going to show the value of the model on the right. That's it.